Last question. A soccer player is going to kick a ball along the equation negative 0.5 x squared plus 8x, where y is the height of the ball above the ground and x is the distance from the soccer player in feet. Draw a diagram of this situation. So the diagram is a soccer player on the ground, kicking a ball through the air, and that ball is going to make a wonderful parabola. It's going to go up and it's going to come back down. Okay, mark the x-axis and the y-axis. All right, well, I'm going to make this my x-axis, which is the ground, and I'm going to make this my y-axis, which is the distance above the ground of the ball. So there's my x-axis, there's my y-axis, and there's my ball. Calculate the y-intercept. Well, the way I've set things up, my y-intercept will be at 0. It's going to be right here as soon as we kick it. If I want to check if that makes sense, from diagram, I see that the y-intercept equals 0. If I want to check it, what I do is I take y equals the equation, and we're going to set x equals 0, because that's how you find a y-intercept. Plugging in 0 for x squared gives me 0 here, gives me 0 here, and we come up with y equals 0. So it works. My diagram seems to make sense with the equation. Factor the equation as fully as possible. Well, that is a really interesting question, because this is not a trinomial. So we're not going to be able to factor it like a trinomial. This is a binomial. The type of factoring that we do with binomials is common factoring. So we want to know what's common in both. The truth of the matter is they both have an x in them. So I can common factor out an x and be left with this. The other choice that I have is I could common factor out more than just the x. I could also common factor out the negative 0.5 and the x, which will leave me with negative 0.5 x squared divided by negative 0.5 x is x, and positive 8x divided by negative 0.5 x is going to leave me with, I better check it, 8 divided by 0.5 negative equals 16. And both of those are considered factored fully, and I will accept both. May I suggest you do this one more often than this one? But this is fine too, especially if the numbers work out nicely. So these are factored fully. Now, one thing I'd like to point out, just in case you're a little bit confused on that and that really bothered you, let's go back and think about this one more time. Y equals negative 0.5 x squared plus 8x. That could be thought of negative 0.5 x times x plus 8 times x. So that x squared is actually x times x. I think you would agree with me now, looking at it like this, that we can easily see that they both have a multiple of x in them. This term has a multiple of x, and so does this term. So common factoring out that multiple of x will leave us with that multiple of x coming outside. And if we were to put it back in, you would see that we'd go back to the original. So now, calculate the x-intercepts and mark these on your diagram. Well, for an x-intercept, you're going to set y equals 0. Depending on which one of these you use, depends on how easy this is going to be. Let's say we use the first one that I came up with. The reason why we factored these is because we've set up two things to equal 0 now. If I set y equals to 0, I've got 0 equals x negative 0.5x plus 8. And I've got two things that multiply to give 0. So if the first one equals 0, then what we say is x equals 0. But what if the second one equals 0? We may have to do a little bit of work for that. So we're going to take the 8 over to the other side. We're going to divide both sides by negative 0.5. And we're going to get an answer of 16. And that works just fine. The other option is that if we were to use this one, we again have created two things that multiply to give us 0 when we set y equal to 0. The only difference is seeing what these values are is a little bit easier when y equals 0. If the first one is 0, we notice that x just must be 0. And for the second one to be 0, we can see right off the bat x must be 16. So there's no free lunches in life, and what that means is if you factor it this way, it's a little bit harder but easier to find the zeros. If you factor it this way, it's a little bit easier to factor, but finding the zeros takes a little bit more work. Doesn't matter which one you do, but we have to be able to do it one way or another. So next, we have to calculate the vertex. Well, to do that, we need to find the axis of symmetry. The axis of symmetry is going to be located halfway between the two zeros. So it's going to be 0 plus 16 divided by 2, which is 8. So my axis of symmetry is at x equals 8. So we know the x value for the vertex. So if I go up and take a look at this, I now know that my axis of symmetry is going to run right down there. And that this is at x equals 8, which means that it's going to be 8 meters from when it gets kicked. But to get the vertex, I not only need an 8 for the x value, I need a y value. To get that y value, I'm going to sub x equals 8 either. Now this is neat. I can sub it in here, I can sub it in here, or I can sub it into the original equation. And it doesn't matter. So the easiest one, I think, might be to sub it into this one. So I'm going to sub it into. So what I'm subbing in is x equals 8. So I'm going to get y equals negative 0.5 times 8. And 8 minus 16. 0.5 times 8 is negative 4. 8 minus 16 is negative 4. No. 8 minus 16 is negative 8. Negative 4 times 8 is, I don't want to make a mistake, 32. So that means my vertex is going to be at 8, 32, which means that this point here is 32. Now, again, this substituting of this value could have gone into here, which I did, could have gone into here, and you'd get the same answer, or can go all the way back up into the original. And that is perfectly fine. You'll get the same answer of 32. So, some questions. How far away from the player does the ball land? Well, it's going to hit 8 meters. It's going to hit its maximum. It's going to take another 8 meters to hit the ground. So that's going to be at 16. Or we could have looked at the Xintercepts. So it's 16 feet. Oh, did I say meters? They're feet. I'm sorry. And what is the maximum height reached by the ball? 32 feet. Okay, ladies and gentlemen, your work now is to do the practice questions that are following it, and then check in for session number 4.